back here, I'm talking about binomial probability distributions in particular, right? I discussed, you know, the requirements to be binomial. I'll probably reference them also in this example. And again, in another video, I talked about how to use the graphing calculator to calculate binomial cases. And I'm going to use that for this video too. I'm not going to do it with the formula. So, all right, let's look at my new problem, okay? Based on a Harris interactive poll, 20% of adults believe in reincarnation. I'm taking this example from a Triola statistics book. Assume that 6 adults are randomly selected and find the indicated probability. What is the blah, blah, blah. Now, before I can use the methods that I just referred to before I can use binomial cases, I want to check to make sure the requirements are met, okay? And again, I told you I'm not always going to do this, but I'll do it again just to reference, you know, the requirements for a binomial probability distribution. I need a fixed number of trials. Do I have a fixed number of trials? Yes, 6 adults, right, are randomly selected. So I have a fixed number of trials. Let me change my color. So n is 6. What's my next requirement? Are the trials independent? Yeah, the trials are independent. You know, one person believing in reincarnation shouldn't affect another person believing in reincarnation if they're randomly selected, right? We're not talking about families or anything like that. Third requirement, 2 outcomes, success or failure. Yes, 2 outcomes, success or failure. Let me define my success. We'll say success will be believing in reincarnation. I'm not agreeing with it or disagreeing. I'm just, you know, defining based on what I want to find statistically. So failure would be not believing, okay? So don't get mad at me if, you know, I define something one way and whatever, okay? I'm not saying I believe or I don't believe, okay? This is just an example, statistically speaking. There are only 2 outcomes. The probability of success, which in this case, the probability of believing, should be the same. So 20% of adults believe, so the probability of somebody believing in reincarnation is 20%. So the probability of success stays the same for each trial, so therefore that requirement is met, and yes, we can use our binomial stuff to be able to calculate whatever I want to calculate, okay? So let me pull it to the next page. All right, so now let's go and actually do some stuff here. Based on what we already determined, it is binomial. Now let's see if we can answer the questions based on that. So we said that n was 6, right? 6 adults. Let me use red, it's a little brighter. N is 6. 6 adults are randomly selected. The probability of success, small p, is 0.2, 20% chance. Therefore, Q, 1 minus p, is the probability of failure, 1 minus 0.2, or 0.8, 80% chance that they don't believe, right, in reincarnation. Understand what the variables are representing and what they mean. Part A, what is the probability that exactly 5 of the selected adults believe in reincarnation? Find the probability that I have 5 successes in n or 6 trials. Find P of 5. Okay, 5 successes in n trials. It's binomial, so therefore I can use binomial PDF. Right? N is 6, P is 0.2, and X is 5. So I'm going to go to my calculator, find my binom, which is second vars, down to binom PDF. Binom PDF, don't confuse it with CDF, I might talk about that later. Number of trials was, what was N? Was 6. P, probability of success, was 0.2. And the X value, I wanted to know 5 out of the 6. 5 successes in 6 trials. Binom PDF 6.25 is really small, approximately 0.1. So approximately 0.002 or 0.2%. That's really low. So that means if I randomly select 6 adults, the probability that exactly 5 out of those 6 believing in reincarnation is 0.2%. That's very small. But I guess that sounds realistic, right? You want to always think, does the situation sound, logically realistic, common sense wise? Does that make sense? Okay, let's do part B. What is the probability that all of the selected adults believe in reincarnation? So now X is 6. So again, I'm only changing X if I'm taking the same situation. Find the probability that I have 6 successes in 6 trials, binom PDF, 6.26. So to my calculator, second vars down to binom PDF, 6 trials, 20% chance of success. That's not changing, but my X value I want now is 6. I'm assuming the probability is going to go down because of the fact that, 5 successes in 6 trials was so low. So 6 successes in 6 trials are going to go down. Look at that. It did go down. 6.4 times 10 to the negative 5. That's scientific notation, approximately 0.1234, So this is not in percentage form. Move the decimal 2 places to the right, 0.0064%. I would say that this is highly unlikely that I go to 6 random people and I ask them if they believe in reincarnation and all 6 are going to say yes. Highly unlikely. That's extremely low. It's unlikely too that 5 out of the 6 are going to say yes. What is the probability that at least 5 believe in reincarnation? So this is an interesting question. At least 5 means 5 or more. So that's important. At least 5. That's 5 or 6, right? That means I want to determine the probability of 5 plus the probability of 6. So now I have to do binom PDF twice. I have to do it for 5 successes and I have to do it for 6 successes. Now because I kind of already did that up here, I could just copy that down. But let's assume that I didn't have A and B and I wanted to go straight to part C. How do I just plug that in? I do binom PDF. N was 6.25 plus binom PDF 6.26. So this represents the probability of 5 and this represents the probability of 6. And I can go, do all that in my calculator in one shot. Second vars, binom PDF down to binom PDF. 6 trials, 0.2, and then 5 successes, plus binom PDF, 6 trials, 20% chance of success, 6 successes, so I'm adding them together, and it does it for me, 0.0016. So approximately 0.0016 or 0.16%. It's still extremely unlikely to happen. If 6 adults are randomly selected, is 5 a significantly high number who believe in reincarnation? I would say yes to that, right? Because if you look at look at this. The probability of 5 of them believing is 0.2%. The probability of 6 of them believing is 0.0064%. The probability of more than 5 or more believing is 0.16%. So I would say that that is a significantly high number. It's highly unlikely for that to happen, for them to all believe in reincarnation.